2025 A-Level Combined Mathematics Paper 1 Part A question number 5, the limit question. This limit question is asking us to show that the limit as x approaches 0 of tan x minus sin x divided by x multiplied by this whole thing, which is the square root of 3x squared plus 1 minus the square root of x squared plus 1 is equal to half. In order to do this, what we're going to have to do is to break this limit into smaller limit pieces that we can more easily solve. So to start off, what we can see right off the bat is that the numerator is tan of x minus sin of x, which means that if we break tan of x into sin of x divided by cosine of x, there is a sin of x factor in the numerator. Now we can see on the denominator there's a divide by x factor. If we take those factors out, we get sin of x divided by x. As we know from the famous result, if we have the limit as x approaches 0 of sin of x divided by x, this is equal to 1, which means that if we can somehow get this sin of x divided by x part out of this entire limit, it can easily be substituted with 1. So what we're going to do in the first step is exactly that. We're going to take the sin of x factor out of the numerator and write the sin of x divided by x component separately. So if you do that, this limit here, the limit as x approaches 0 of tan of x minus sin of x divided by x multiplied by the square root of 3x squared plus 1 minus the square root of x squared plus 1 is going to be equal to the limit as x approaches 0 of sin of x divided by x times the rest. Now in this case, the rest is going to be what happens when you remove sin of x from tan of x, which is going to be 1 divided by cosine of x, minus what happens when you remove sin of x from sin of x, which is going to be 1, divided by this bit here, which is going to be the square root of 3x squared plus 1 minus the square root of x squared plus 1. Now, in order to simplify further, what we're going to first do is to multiply the top and bottom of this thing by cosine of x, and by doing so, we can get this thing into the form 1 minus cosine of x divided by cosine of x. So we're going to do that real quick. We're going to have this part being equal to the limit as x approaches 0 of sine of x divided by x multiplied by 1 minus cosine of x divided by cosine of x, which is coming from this part here. If we take the common denominator of cosine of x, this is what we get. Now, for this part here, we're going to rewrite that directly as is, as being equal to 1 divided by the square root of 3x squared plus 1 minus the square root of x squared plus 1. Now, in the case of this thing here, we have a bit of a problem. Because if we substitute x equals 0 into this thing directly, we can see we get 3 times 0 squared, which is 0 plus 1. So the square root of that is going to be 1 minus 0 squared plus 1, which is going to be 1. So we get 1 minus 1, which means that the denominator here is equal to 0. So therefore, this term here is 1 divided by 0, which is undefined. In order to fix this, what we're going to have to do is to multiply the top and the bottom here by what we call the conjugate. In this case, since we have the square root of 3x squared plus 1 minus the square root of x squared plus 1, what we're going to want to do is to multiply the top and the bottom by this thing plus this thing. Because if you have a minus b, where a is going to equal b as you take the limit, if you multiply the top and the bottom by a plus b, what you're going to get on top is a plus b, and on the bottom you're going to get a squared minus b squared. So if we just do that, if we multiply the top and the bottom by the square root of 3x squared plus 1 plus the square root of x squared plus 1, and then divided by the same thing, the square root of 3x squared plus 1 plus the square root of x squared plus 1. Since when the limit of x approaches 0 is applied to this thing here, it's not equal to 0 divided by 0, there is no problem with multiplying by this thing. But now if we multiply by this thing, we see that something interesting happens. If we multiply this thing, the top is going to remain as this part, but the bottom is going to be the difference of squares of this part and this part, which is going to be the square of this thing, which is 3x squared plus 1 minus the square of this thing, which will be x squared plus 1. So if we write that part down, this is going to be equal to the limit as x approaches 0 of sine of x divided by x, and I'm going to leave this part for a little bit. I'm going to leave it as a blank space because I'm going to want to do some more simplification with this part. For the next part, on top we're going to have the square root of 3x squared plus 1 plus the square root of x squared plus 1, and the denominator we're going to have 3x squared plus 1 minus x squared minus 1, since we are subtracting x squared plus 1. So now for this bit here, what I want to do is to leave the denominator as it is as cosine of x, but for the numerator we're going to apply the identity that 1 minus cosine of x is equal to 2 times the sine squared of x divided by 2. This can be found using the double angle formula. So using the double angle formula, we know that this is equal to 1 minus cosine of x is equal to 2 times the sine squared of x divided by 2. So now let's simplify. If we start simplifying, we get the limit as x approaches 0 of sine of x divided by x, which we can't really do much else about for now. We're going to be replacing this with 1 later using this identity up here, but for now we are going to leave it. For the next bit, we have a 2, which we're going to take out as a 2, and then times the sine squared of x divided by 2, which I'm going to leave as is, and then times a 1 divided by cosine of x. And as for this bit, if we simplify this bit, on top we can't really do anything. It's going to be 3x squared plus 1 plus the square root of x squared plus 1, and on the bottom, if we simplify, we have 3 times x squared plus 1 minus x squared minus 1. The plus 1 and the minus 1 cancel, and 3x squared minus x squared is going to be 2x squared. Now we can see that this 2 and this 2 are going to cancel. If we cancel them out, we can see we're left with a bunch of terms like this. So now what we're going to do is to start manipulating these terms and put them next to each other in interesting ways. So first off, we're going to break this limit into pieces since all of these functions are being multiplied together. So the first piece we're going to break is going to be the limit as x approaches 0 of sine of x divided by x, since this can be directly replaced with 1. The next part we're going to break is going to be coming from the sine squared of x divided by 2 and this x squared. Since we have the sine squared of x divided by 2 here and we have x squared divided by here, we can see that we could replace this with the limit as x approaches 0 of sine of x divided by 2 divided by x divided by 2 whole thing squared. Now we can do this, and you'll note, in order to get this x divided by 2 squared here, this x squared needs to actually be x squared divided by 4. But in order to get that x squared divided by 4, we need to then again multiply by 4. So we're going to multiply by 4 to compensate that out. So now that we have the denominator needs to be multiplied by 4. Now we can take this multiplied by 4 out and get a divide by 4. So we get 1 divided by 4 here. And then finally, we can see we have a last limit here, which is going to be the limit as x approaches 0 of the square root of 3x squared plus 1 plus the square root of x squared plus 1. So now we can see we have a bunch of different limits that we have to solve. But each of those limits are actually simple to solve. If we look at the first one, it's just the limit as x approaches 0 of sine x divided by x. So we can see that that limit is going to be equal to 1. We need to then multiply that by the next limit, which is the limit as x approaches 0 of sine of x divided by 2 divided by x divided by 2 squared. Now, the limit of a function squared is equal to the limit of the function whole thing squared. And the reason for that is that if you have two limits and you multiply them together, the product of the limit is the limit of the product. So for that reason, this is equal to the limit of x approaches 0 of sine x divided by 2 divided by x divided by 2 whole thing squared. And that is going to be equal to 1 squared. So this whole thing is going to evaluate into 1 squared. As for the next bit, we have a 1/4. And finally, the limit as x approaches 0 of the square root of 3x squared plus 1 plus the square root of x squared plus 1 is going to be the limit as x approaches 0 of the square root of 0 plus 1, which is going to be 1, plus the limit as x approaches 0 of the square root of x squared plus 1, which is going to be 0 plus 1 square root, which is going to be 1. So therefore the last limit is going to be 1 plus 1. Now if we simplify all of this, the 1 goes, the 1 squared goes, the 1/4 stays as it is, and this bit turns into 2. So therefore we have 1/4 times 2, which is going to be 1/2. And that is the answer we are expecting. So we can see we got the answer we expected, and we did so with all of this simplification here. So that's going to be our final answer. You could make this a little bit neater, like, you could structure the lines a little bit nicer. Of course, my handwriting with this pen right here is not that good since it's a digital pen. So you would write this nicer, but overall, this is going to be the structure of your answer. Now, it should be noted that there are alternative methods that you could use in order to get this 1/2 answer. This is just one of them. You could do other trigonometric substitutions and things like that. But for now, we're just going to use these trigonometric substitutions and this method in order to get our final answer of 1/2. So now let's take a look at the marks you get for your solution. In your solution, for finding that sine of x divided by x as limit as x approaches 0 equals 1 and using it somewhere, you get 5 marks. So either you could get that 5 marks for this application here, or if they don't see that you substituted it but you substituted it over here or something, you will get that 5 marks. The next 5 marks is going to be awarded to multiplying by the conjugate like this, because multiplying by the conjugate like this eliminates the 1 divided by 0 that you previously had. So that's going to give you another 5 marks. So for this bit here, you get another 5 marks. The next bit that you're going to get 5 marks for is going to be the substitution of 1 minus cosine of x with 2 times the sine squared of x, and then using that, simplifying downward to sine of x divided by x formats. The next mark that you're going to get is going to be for this limit here, which we are going to simplify in order to get the 1 plus 1, which is 2 over here. And finally, the last mark you're going to get is going to be for the overall structure of this bit here, where you have the limit as x approaches 0 of sine of the value x divided by 2 divided by that value x divided by 2 whole thing squared being equal to 1 squared. So you get a mark here as well. So this is going to be the distribution of marks for this question. You can see things like this common limit here are going to give you marks, things like multiplying by the conjugate are going to give you marks, and things like trigonometric substitutions are going to give you marks. And finally, of course, something like simply simplifying this limit downward is going to give you marks as well. So that's the summary of this question. I hope you've enjoyed. Post any comments that you have in the comments down below. Thank you for watching and goodbye.